assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this problem, we're given a particle that is moving between two parallel plates and it's going rightwards and it is slowing down as it does so. And for the first part, we need to determine if the particle is either an electron or a proton. So we can do this by considering the sign of the charge. So a proton has positive charge, an electron has a negative charge. Now we can do this by drawing the electric field lines between these two parallel plates. Note that the electric field lines go from a region of higher potential to lower potential, so they'll be going in this direction. That means the net force on a positively charged particle will be in this direction. Now, since the electron is slowing down from its initial velocity, so it's traveling rightwards and it's slowing down, it's experiencing an acceleration in the leftward direction. That means the force is also in the leftward direction. Now this direction aligns with the electric field. That means that the charge is positive and therefore our particle is a proton. Now we need to find the speed as it reaches plate 2. For that, we will consider the amount of work done on the particle by the field. Now the formula for work done is equal to delta V times Q. Now delta V is just the difference between these two parallel plates, and that's going to be 20 volts. The charge on the proton is the elementary charge, that is 1.602 into 10 to the negative 19 coulombs. And this just turns out to be, after multiplication, you can use a calculator. So this is 3.20 into 10 to the negative 18 joules of work. So this much work has been done on the proton in the opposite direction. Now, since the work has been done in the opposite direction of the direction of travel, it's actually decreasing its kinetic energy. Now let's find the initial kinetic energy first. So the initial kinetic energy, KEI, was given by 1/2 times the mass of the proton times the velocity v squared. Now the mass of a proton is 1 atomic mass unit, which is equal to 1.66 into 10 to the negative 27 kilograms, times the velocity squared, which is 90 kilometers per second. That is 90 times 1,000 meters per second squared. That gives us an initial kinetic energy of 6.72 into 10 to the negative 18 joules. Now, since the work was done against the particle, the final kinetic energy will be the initial kinetic energy, which is 6.72 into 10 to the negative 18 minus the work done by the field on the particle. So this will just turn out to be 3.52 into 10 to the negative 18 joules. Now that's given, now the kinetic energy is given by the formula 1/2 mv squared. So our required velocity is just 2 times 3.52 into 10 to the negative 18 divided by the mass of the proton, which is 1.66 into 10 to the negative 27 kilograms, and we can take the entire thing in the square root, and that gives us 65.1 into 10 to the 3 meters per second, or 6.51 into 10 to the 4 meters per second if you prefer scientific notation, or 65 kilometers per second if you prefer that particular unit. And these are our required answers.